ready for launch this morning.
On a clear night in California, here we go. T-minus 10, 9. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Liftoff of the Atlas V, carrying JPSS-2 and lofted, a new weather observatory for our planet, and a test for planetary exploration.
Atlas VU has gone to closed loop control.
Yeah, Daryl, as we heard Omar Baez say, LSP-100 on its way also. We're very happy for this 100th mission, the Launch Services Program. Let's listen in as Jesse Gonzalez.
And coming up on 30 seconds into flight, vehicle is a half-mile in altitude, 2 miles downrange, traveling at 160 miles per hour.
Programmed in, but now closed loop is taking positional feedback from the rocket sensors to get it into the proper line for trajectory. It's going to maintain that ascent line. Beautiful shot there on board. A shot from our infrared camera.
And the reaction control system has reached flight levels.
Centaur engine in second stage to prepare for its super chilled propellants to flow through the booster.
About 3 minutes and 15 seconds into flight, vehicle is now 53 miles in altitude, 67 miles downrange, traveling at 5,800 miles per hour. And we have successful stage separation.
With stage separation,
and
now onto the Centaur.
On the RL-10. And we have ignition for the first burn. RL-10 start parameters look good. And we have good indication of payload fairing jettison.
Saw a shot of that booster floating off into space.
Yeah, you can actually see the 4-meter fairing going by there too on the video. That's a great thing. Looking at the telemetry data, RD-180 performed very well on the first stage. Separation was clean. Payload fairings, you can see on the infrared video there on the screen. The booster falling away, and as the vehicle is moving through space, we're trying to keep everything as stable as possible. So we have an X, Y, and a Z body rate on the Centaur, and the flight computer and the RCS system continue to maintain that as we move through to get ready for separation.
And now we're moving to ULA's real-time animation.
6 minutes in flight, the vehicle is now 250 miles in altitude, 430 miles downrange, traveling at 9,400 miles per hour.
The animation is informed by real-time data.
Car will coast for approximately another 15 minutes prior to MES-2. Continuing to see good performance out of RCS, very stable tank pressures, and very stable body rate.
And as you look at this animation of Centaur, there's still a vehicle attached to it. That's lofted, encased at the end, the far left end of the vehicle, lofted inside of a payload adapter that once held JPSS-2. It's now been released. And this is the second part of the flight, the primary mission now accomplished. We're looking for that acquisition of signal from JPSS-2, but also transitioning now to the lofted tech demonstration.
Yeah, absolutely, Daryl. As the team is continuing its slow playback of some of the data through the TDRS network for that video that we hope to see.
And to celebrate the launch of JPSS-2, NOAA asked for photos of the places you love, places the satellite will protect by observing the Earth, atmosphere, and our oceans.
And we have main engine start 2.
Okay, now
RL-10 operating parameters are looking good, stabilizing very quickly. And Centaur body rates are stabilizing nicely following the burn. And we have MECO 2.
So just like that, the burn is
RL-10
over.
Shutdown parameters look good for the second burn as well.
Let's take a look at some video that we just downlinked a few moments ago. This was of a huge milestone, the release of JPSS-2. There it goes, from the Centaur upper stage off into space.
And you can see in that picture right there, Daryl, not only is J2 separating from the stack, but that whole stack of metal that we see that it's separated from, lofted, is inside those adapter cones and protected right now. And that's a
rings 15 times stronger. 2,900 degrees Fahrenheit. That is hot. And as Mick and Daryl have been talking about today,
jettisoned. The cover has been released, and Sean, that image there shows us that lofted has been inflated.
Yeah, so the payload adapter separates, that releases some pyro inhibits that allows us. We don't have any way of verifying with data from the vehicle, so they're just marked as expected based on the time elapsed in the mission. The ones that show up as green.
And we have successful indication of separation of the lofted reentry vehicle.
And there it goes. Lofted's on its way back down to Earth, Sean.
So we're free flying now, and this is great news because now that we're separate, the lofted vehicle turns on a real-time beacon and we'll start transmitting data. So we'll be able to confirm some of these images that we're seeing on the computer model.
We got a little bit of time.
Small heat shield inside your rocket diameter. With HIAD, when the fairing comes off, the heat shield can then inflate and expand to a diameter much larger than your rocket. Therefore, you're able to bring in a much larger payload than you were before. So how do spacecraft slow down? You have retro propulsion, you've got your...
Yes, we were very, well, there was some discussion within the group about how it would inflate. Because we've never seen this inflate in an orbital sense, and so we were very happy to see that it inflated and there were no snags or anything. This was one of the highest risk parts of the mission.
Exactly, and there we see the replay of the moment of separation. The lofted return vehicle coming off of the Centaur, heading back towards Earth. This is not a view you often see. Centaur coming to a standstill after putting lofted back, and there it is, falling back to Earth.
Yeah, so we're falling towards Earth. We're going to start accelerating, and then we'll...
And I guess from what we expected, I'm a little surprised to still see it up in the air, Sean.
Well, I don't think this is live video.
I think this is replay?
Yeah, I think this is recorded video. Oh,
there
yeah,
could be a delay in the signal, but there it is.
You can definitely see the air shell, and it's bright because it's warm, and then the parachute up above it.
The red-hot bottom of the accelerator, the decelerator rather, the inflatable decelerator, and above it, the parachute fully deployed. Away from Hawaii, we have a GPS camera tracking the return of the lofted return vehicle from outer space. This is a technology demonstration to show that we can bring back... It took on so much heat as it came back in through the atmosphere. And since it's elliptical in nature, Sean, here's splashdown.
Oh, we're about to splash down.
There it goes.
And we're in the water now.
And you can see the parachute now collapsing, no longer suspending lofted because it is down in the water. Clearly, this is also beyond the horizon.